I, s- I can see multiple people joining now. Let us wait for a few more minutes so that we can have more number of audience right now. So I thank you so much, Amit, Jesh, Khushbu, Palanivel, Mayank, Praveen, Ruxana, Khatun, Subhangi, Suhani. Thank you so much for joining this webinar. And we keep on doing such webinars on a regular basis. So I would like you to comment on the chat box from which city you are in, from which company you are, something about yourself, please. Go ahead and buzz around the chat. Amit Kumar is from Pune. I can see Khushbu from Mumbai, Mayank from Delhi, Shubhangi from Pune, Praveen from Pune, Neil Soft. Okay, welcome Praveen, Shubhangi, Mayank. Rest all others, please ping on the chat box from where you are. What is your designation and from which city you are? Okay, Swani is from Noida. Great, welcome Swani. Right, we'll wait for one more minute and let people join in, and we will start shortly for the amazing webinar session of Meteonic Innovation, joined collaboratively with Perforce, and we have a very interesting topic: impact of static code analysis on AI-driven project. Yes, I can see Ria has also joined. Hey, hi Ria, hi Raja Kumar, hi Rizwan Roshan. Please comment on the chat box which city you are from, please.
And which company also. If we
Yes,
can.
Hi Ajinkya. Please drop a message on chat box which company you are from, which city you are from. Okay, I think we can start now. So hello everyone and welcome to our webinar on impact of static code analysis on AI-driven projects. So my name is Akash Singh and I'm regional sales head at Meteonic Innovation, and I'm thrilled to be your host today. Thank you for joining us. So, before we dive into the main topic, let me tell you a bit about Meteonic Innovation. So, we are an 18-year-old organization with a mission centered around empowering software community, right? So, we bring around world-class, state-of-art solutions to ensure you have best tools for your development. We also focus on enabling young talent like you guys and help them to use softwares better, and we so that they can become more efficient in the development phase, right? So compliance is a key aspect of our solution, right? And we are dedicated to save your time while securing your asset and improve your security posture. So I'll introduce you to the topic today, right? It's a fantastic topic: impact of static code analysis on AI-driven projects. So artificial intelligence is transforming the world of software development. But with this great power comes great responsibility. A famous dialogue from movie Spider-Man. So today we will explore how static code analysis can impact AI-driven projects, ensuring safety, efficiency, and compliance in this rapid evolving landscape. So today we are going to cover artificial intelligence, risk and reward, implications for functional safety, implications for cybersecurity, and harnessing AI in static analysis. So we'll also have a Q&A session. So chat box is open for you guys. Please feel free to drop your questions anytime. We'll try to address them as soon as possible, and we'll look into the question answer box we'll address them as soon as possible. So, Pooja, can we start a poll so that we can get some interest from the attendees, what topic they are interested in and how they are seeing this webinar?
I
So
think
we have, yes,
there is an interesting comment. The title itself seems to be a little unclear. So that's good. People are thinking
yes.
about that. So I'm sure Steve is here to help with that. Yeah, go ahead, Akash.
So first poll is, how confident are you in the current standards ability to ensure the safety of AI system in critical applications? Can I have answers, please? Everyone, please be quick. We have 15 seconds now. Last 5 seconds, please. Okay, we have got higher percentage on somewhat confident side. Very confident is 33%, not very confident 28%. Perfect.
So
So I'm pleased to introduce our esteemed speaker for today, Mr. Steve Howard. So Steve Howard, Director of Product Static Analysis Tool. Steve is having almost 20 years of experience in software verification and validation. He has been primarily working with static analysis tool. Steve is first class graduate from computer science from University of Wales and several postgraduate qualifications in software testing and safety certification. So without further ado, I'm pleased to hand over the session to our speaker, Steve Howard. Over to you, Steve.
Thank you, Akash. And honestly, I didn't realize it was that old, but it's come around fast. So thank you very much. Okay, so today, as Akash mentioned, we're going to focus, first of all, just a quick summary of the general status of artificial intelligence as we are now. And then we're really going to focus on the body of this presentation, which is all to do with the implications of artificial intelligence for our software development in functional safety and cybersecurity for mission critical systems. So really that's where we're focusing. What is it that we need to be aware of and what do we need to do in order to make sure these systems that are AI backed in some form are both safe and secure. And then at the end, we'll just give you a little bit of a taster of the kind of things we're already looking at in terms of using AI in our own products. So actually helping to use AI in the static analysis that's giving you the safety and the cybersecurity compliance. So that's really where we're going. So first of all, as we say, just the risk and rewards that we know about already. I think we're all probably very familiar with tools like ChatGPT. And honestly, I know in India we have a tradition of very long weddings, and I can't imagine what it's like there. But certainly in the UK now, if you go to an average wedding, you can pretty much guarantee that at least part of the best man speech is written by some sort of AI tool. And my kids know this as well. When they're writing their homework, they're just inherently using AI to help them research in particular, and then to turn that information into something that's consumable for their teachers and lecturers. So we all have AI touching our lives as it is, but really the worry that we have from more of an embedded systems space is when the AI is interacting in impactful domains. So we're talking about things like energy storage or medical systems or autonomous vehicles, then we have to have an extra level of concern. Rightly so. We know that AI is already, being used in things like agricultural robots or medical systems. AI has proven a very valuable tool in interpreting big data from diagnostic systems. So perhaps when you have scans for cancers with CT scanners or MRI scanners, we're seeing that AI is able to detect anomalies within those images that we're taking that can help us diagnose correctly these kind of illnesses, which is very, very valuable. So we know it's valuable. We just need to be careful in how we use it. And of course, there's several areas in which AI can be used in our embedded mission critical systems. So one of the areas that we're already seeing, and we're using it ourselves in-house here in Perforce, is writing the code. So tools like GitHub Copilot are actually able to create the code for us for various things. They can help us both with the coding and the reviewing of the code. And so that is claimed gives us a much faster coding capability. The question is whether the code that we're creating in this way can be relied upon. And what do we even mean by that statement? What do we mean by saying relied upon? So that's what we're going to investigate really today through this course. First of all, are AI systems safe? So this is the question that we are asking ourselves now as AI is creeping into those mission critical systems. And we're very much guided by what we've already done with existing systems, of course, and that generally is through regulation and compliance to those regulatory requirements. So functional safety standards are very well evolved. We've been using them in applications like automotive, medical systems, industrial controls, aviation. All of these things have used functional safety standards for a number of years, many years, and in fact forever in the case of some of them. But do these standards still work for AI systems or systems that are harnessing AI in some form? That's the question we'd like to answer. Things are developing. So we already have, for example, in the EU, and I'm sure you have something very similar in India, there is now guidance with Article 15 around high-risk AI systems that need to be designed to be accurate, robust, and secure. So those are the points we're really sort of trying to cover. Now, this is very, very high level. And in the case of the EU Artificial Intelligence Act, it does define high-risk AI systems, including anything with safety components, but particularly with critical infrastructure, i.e. road traffic management, water supply, heating and electricity supply for our countries. At a government level, this is what they are thinking about with high-risk AI systems. If we're going to use them, they need to be reliable. Of course, we don't want the water supply stopping in our country, and they have to be secure because we don't want an external bad actor having control. So these are very important points, and it's how we deal with that from an AI perspective. Similarly, the US executive order on safe, secure, and trustworthy development and use of artificial intelligence. So again, very similar wording. It's very similar high-level kind of guidance from a government-level requirement as to what they think they need to do. So this is kind of where we're at in terms of top-level, high-level, government-level sort of interpretation of what's required. But resilience is a word that's used in the US executive order, and that's something we see time and again, actually in many of the standards now filtering down from this. So, requirements for the providers of high-risk AI systems, in summary, actually relates to risk. Establishing a risk management system. Now, this is not unusual. We have risk management systems for so many things at that very, very high government level requirement, financial systems and so on. All of them have this kind of idea of risk management. We can't eliminate problems, but we can manage the risk of problems. So we need to conduct governance around the data, making sure we have training and validation, testing, and all of these things, and make sure that those things are sufficient and representative. So we're doing our best to try and make ourselves free of errors and follow the intended purpose. We need to draw up technical documentation to make sure we know what compliance is actually required and what we're doing in order to show compliance, and provide that information to any auditing authorities. We need to design, achieve appropriate levels of accuracy, robustness, and cybersecurity in our products. So we're designing to achieve that from the actual development perspective. One of the great things there for us would be, for example, ensuring that the code is robust and secure from the ground up. And of course, we would want to establish a quality management system to ensure compliance. So this is what we're going to use to keep ourselves compliant, a QMS system. So that's general requirements from government level, or even above government in the case of the EU. It's not one government, it's a joint government initiative in terms of trying to work out what we need to have at the highest level. But what does that actually boil down to in terms of functional safety itself? So functional safety, very, very specific. We all know what that means if we're working in those industries like automotive, medical systems, and so on. But what does it now mean from an AI perspective? So first of all, what is functional safety? Well, functional safety is designed to protect users from technology. For example, we can't have a steering system in an automotive vehicle where if you turn the steering wheel left, the vehicle actually moves to the right. That would be extremely dangerous from a control perspective of the vehicle. And so we need to protect a user from technology if it were to go wrong in that scenario. Similarly, we also need to protect technology from users. So we can actually inadvertently, as a user, use the technology in the wrong way to do something that really would damage the technology as well. So for example, in power grids or power management, we wouldn't want users to do things that would overload the system and cause a major outage or destroy the whole system entirely. So that, again, we actually need to protect the technology sometimes from the users doing something stupid. So all of these things are part of what functional safety is, and the protective measures that we implement in functional safety standards are to eliminate or at least mitigate the hazards caused by failure or unintended behavior of the system. So this is very important, of course, in a safety critical system. We want to make sure that the system behaves as it should, and if there is a failure of some kind, that we give the user the best possible chance to mitigate the hazard. That's what we're attempting to achieve with functional safety. And we do that through the standards, and they prevent system failures generally. So we're trying to make sure that the system will not fail in the first place, especially if it's hazardous to human health or it's life-threatening in some form. For example, we don't want the braking system in our vehicle to fail. So that's the first step. But if that system does fail, we need to find ways to minimize the risks associated and try to minimize the risks associated also in the product development. So systems covered under functional safety, when we're working to functional safety standards, are designed to automatically prevent dangerous failures, first of all. And if they do fail, for example, our brakes do fail, we want to have a warning light or something so that the user is then able to know and will be able to react in a sensible way to that failure. So it's a bit of both. It's first of all preventing failures, and then if we do have a failure, what's our mitigation strategy? So that's functional safety, and that's what we're doing under a standard. And really, all of that's done through a set of processes from the management of the overall system. These are very common, of course, in any QMS system, but we're working through the management and the development of the design in the first place, through to the development of the system itself, then into production, and finally into service. And throughout all of those stages of the product lifecycle, or product safety lifecycle, as we sort of think about it in a safety standard, we're making sure that we're implementing verification and validation all the way through, right up to the point of service and decommissioning at the end. So that's how we're going to manage the entire safety life cycle. Functional safety standards are prevalent in most industries where we work with embedded systems in particular. So a classic case of these would be things like automotive, which is the ISO 26262 standard, railway systems, which have just had an update. That's now the 50716 standard, used to be the 50128 standard. Medical devices 62304, aerospace DO 178. It's a well-known standard for civil aviation. Nuclear power has a standard, and also the general industrial standard of 61508, IEC 61508, which is kind of the forerunner or the grandfather standard for many of these. It's the basis on which many of the others are based. So all of those are different standards for different industries, but they all fundamentally kind of follow the same pattern in terms of specifying requirements to help ensure that systems are more safe to use, and in the event of a failure, they will have mitigating strategies. So functional safety and AI, what about this? So first of all, functional safety concentrates on the risks caused by a malfunctioning system. That's all traditionally based on the system being deterministic. If you do this, it will do this. And a malfunction is when it doesn't do that. The problem with AI is that the system is no longer deterministic. By design, AI systems, if it's a running AI system, are intended not to be deterministic. The whole idea is that they're evolving in some form to find better solutions. So we've moved away from having a known deterministic behavior to having to focus on functionality. We can no longer say, this happens, so therefore that will happen. That is not the case once we move into using AI in our systems. And so the definition of the functionality of the system has really become essential. One example of where we've already started to look at this in terms of risk management of unknown functionality is in the SOTIF standards, which is ISO 21448 for automotive. And SOTIF means the safety of the intended functionality, not necessarily the actual functionality in this case, but the intended functionality. So this is something as an existing standard, and ISO 21448 is already out there. It's already used quite widely in automotive for things like autonomous driving, where we can't know the exact behaviors in every single instance. In other words, we're operating in an unknown behavior space, and we're trying to manage risk, we're trying to manage misuse, and we're trying to work out where the safety hazards would lie. So SOTIF, an existing standard, would appear to be also quite applicable in the case of AI, where we again do not know the full behavior. And indeed, there are now new standards evolving for functional safety in AI systems. So TR 5469 is one of those such new standards. And this is based around the IEC 61508 standard. So very much based on an existing functional safety standard and updating it to deal with the challenges that are existent from use of AI. So TR 5469 is really how AI algorithms might be evaluated using the framework still of IEC 61508. And at the moment, there is limited information. This is not something that's actually produced yet. It's still in draft, but there is limited information in this case with AI on the specification design and the verification of functionally safe AI systems. So this is still in its infancy, essentially. And there's also limited information on how to apply AI technology for functions that have safety-related effects. So again, the standard is still a little bit light in terms of its detail. But whenever AI is used, and especially related to safety systems, we do need to have some special considerations to deal with those. And there are already techniques available, as we've discussed, that we could apply to AI and AI algorithms, but how can these be measured? The one thing that TR 5469 does do rather nicely is start to identify the uses for AI in different software areas. So they classify it as there being 3 different areas for AI to be used in a system. And those have different levels of risk. So the highest level of risk is associated with using AI in the actual field, so in the system itself. So in other words, we've got a running system that's communicating with an AI model or is based around an AI model, and it is behaving in accordance with the AI decisions in the system. Pardon me. The next level is in the actual development of the system. So now we're talking about things like the GitHub Copilot, where AI is used to actually produce the software, which is then going into the system, which is then running. Now, this has a benefit in that the code itself is now deterministic. So AI was used to create the code, but the actual code that's running in the field is now deterministic and not non-deterministic, as in the first case. So this is a better case for us in terms of the safety. It's reducing the risk. And finally, there's also the use of AI in the tools. And if we use AI in the tooling as part of the development, but not actually producing the code that's then used or anything that's used actually on the system, this is now the third level of risk. So this is the lowest level of risk in terms of the safety path. And so those different levels are then given classifications according to usage levels. So level A would be use in the field, level B is use in development, and C and D are theoretically not involved in the safety path because the tools themselves are helping decide what goes onto the system, but they're not going onto the system that's actually running. And they have classifications from that, where classification is that they need to do something with existing functional safety. Class 2 requires standards, that just give us an appropriate set of requirements, whatever they might be. And class 3 doesn't necessarily need any specific additional techniques. So this is really where this standard is up to. It's not yet ready for publication, but they are making good progress in terms of this definition of different levels of AI usage and the risk associated. More relevant, perhaps, is the fact that there is now also a standard for road vehicles, safety and artificial intelligence, which is the ISO 8800 standard or 8800 standard. And this one is now in the process of being published. So the draft was completed, and this is actually in publishing as we speak this month. So we expect this to be a published standard before the end of 2024. This is specific to automotive, to road vehicles only, but it is the first example of something actually being released to cover AI systems in a functional safety space. It extends ISO 26262, as you'd expect, it's automotive, and it extends the concepts and guidance provided by the 62448 standard, the SOTIF standard, which is then talking about guidance of the intended functionality. So it's kind of merging the concepts of both of those standards, which are already in the automotive space. So this is rather interesting that it's kind of, they've moved quite quick here. So it proposes that risk reduction measures during the design and operation phases will help in an iterative approach to reducing risk. And this is relevant for all AI usage, but can be allocated to two uses: the use of AI for the functionality itself. So in other words, using AI in the process of the system executing. Okay, that's one use. So we can imagine that perhaps in things like autonomous driving, where it's making decisions for us. Or the use of AI actually as a safety mechanism. So, okay, so this is a slightly different thing now. So now we're talking about whether AI is not in the functionality. So it's not making the decision of autonomous driving, and what that might do, but it's used as a safety mechanism, double checking what that decision was, perhaps. So there's another thought of a different classification, essentially, of AI usage in a running system, the decision maker or the overseer. So, as we say, this one is actually now published, or in publishing, sorry, it's officially ready to go. It will be published this month, but it does very specifically talk about verification of AI systems, methods for testing AI components, how we can measure the verification of system integration, the ideas of virtual testing versus physical testing. So obviously physical testing may not be possible for all cases, and virtual testing may offer some good alternatives. And then the overall validation of the system with AI as well. So this is all kind of built into that standard, and we're very excited about that now being pretty much ready to go, which is very recent news. So that's the safety side of things. We're going to talk a little bit about the cybersecurity side, and then potentially we'll just have a quick stop for some questions at that point, because those two are quite closely linked and they're kind of relevant in the same ways. So on the cybersecurity side, again, we have many of the same problems. So the idea is that cybersecurity is a necessary precondition for all of these things that we see being talked about in the EU safety legislation, the US executive orders, and so on and so forth. And say, I'm sure in India there's similar requirements at very high level. The point is that systems, if they are insecure, are not safe. So if they are mission critical, if they are related to government infrastructure, we can't rely on them, we can't trust them if they're insecure, and there are options for external bad actors to take control. AI systems, one of the big problems with them is the fact that they are so quick and high pace in development, and so security can often be overlooked or just not considered in a timely fashion when we probably should be. And so it's important from all of the standards here that what we need to make sure is security is a core requirement, and it's not just sort of an additional thought. Now, there are functional security standards out there. So this is, again, a recent development in our markets in embedded systems, that previously we had functional safety. We talked about security, but there was no functional security standard. And the functional security standard, they have been evolving since around 2018, I think, with 62443 being the first one. And we have other ones like ISO 21434 for the automotive space. So these standards have also evolved fairly rapidly over the last, so 5 or 6 years. And what they require is very similar to what we require in functional safety, but making sure that that applies also for the security. So in other words, it's no good having a car where the systems behave as intended in all cases, everything would be safe, if even in behaving in the right way from the commands given, then an external actor could take control of the vehicle and still choose a bad outcome for the vehicle. Even though the vehicle's doing what it's supposed to do in response to the commands are bad. So in other words, first level, make sure that the vehicle behaves safely and according to the directions from the commands given. Okay, good, that's functional safety. Now we need to protect the vehicle from having external interference that could mean that even though it's behaving correctly, it's still doing something bad. So really, the essential here is that security vulnerabilities allow software to be abused in ways that the developer never intended, but also that the operator or the user is not intending. And that's where we need to guard against those vulnerabilities. So functional security standards, as I say, a relatively recent development. 21434, the ISO standard 21434 for automotive, is a relatively recent development. I think it was 2021 when that was released. But this will be a requirement. So interestingly, although 26262 is highly recommended for US and EU vehicles, it's not actually mandated. 21434 from a security perspective will be mandated. It's going to be a requirement. So that's an interesting difference. But in all cases, these standards essentially require that we have to have some kind of secure software development lifecycle, and that all activities must have some level of security consideration. And all staff must be trained, and so on and so forth. So functional security for AI, there are many guidance papers as well. So for example, the NIST, which is the US National Institute of Security and Technology or whatever, it does require or does provide guidance as to what makes sense for secure software development practices around AI. So they've already produced something on this. The UK National Security Centre, the NSC, they have also provided guidance on this as well. And I'm sure, again, I expect that within Indian government, there's also similar departments working on the same kind of guidelines, if not already published. But those two really are intended to be companion resources and frameworks. So the NIST SP 800 21.8 is really a resource to help people use generative AI and dual use foundation models in a safe and secure way. So the goal is really to identify the practices and tasks that need to address the risks that we're introducing with AI from a security perspective. So overall, all of these standards kind of have the same thing. First of all, we need to raise awareness of the issues. So this is something about training and making sure the staff are aware. We have to model the threats to the system in terms of knowing where the threat vectors are. And we have to design the system well from the ground up. So this was the thing of, making sure that not only have we got functionality and performance that we need, but we also have the security. And we should always consider the security benefits and trade-offs when selecting an AI model. So here's something that actually we're very sort of aware of in terms of what we're looking at for our own tools. What are the security trade-offs when we're using different models? So with that, we'll just have a quick look at any questions at the moment, whether we have any. Akash, do we have anything in about all of the functional safety, functional security topics?
Okay. Please, guys, do you have any questions? Please, you are open to drop your questions in the chat box or in the Q&A box. Please drop your questions. We will be happy to answer them. So, Steve, I do have a question. So you mentioned cybersecurity is another critical area which is upcoming, right? So
Yeah.
AI-driven projects can introduce new vulnerabilities, right?
Yes.
So how to address these kind of vulnerabilities and protect your systems effectively?
Great question. And the thing is, there's very many varied ways in which AI could introduce security vulnerabilities. Now, the classic case, of course, is that we're using some AI engine to help us generate the code. And in that case, it's important that we check what the AI engine has generated for us, because maybe the AI engine was trying to find the quickest way to implement the requirements that we've given it, but it doesn't necessarily consider security. Now, of course, we can train our models so that the tool itself can learn more about the security and where the risks lie. So there's nothing to stop, say, GitLab Copilot being trained to understand better the security risks, and that's very important. So there's a prime example of where we could defend against it, but we can also defend against that by checking for those vulnerabilities as a post process, which is good because then we're doing a double check. Or in a running system, of course, we should be able to detect some of those with dynamic analysis, but that's a little bit harder. Yeah, so that's the main ways.
Steve, I have a question in Q&A box. Given the challenges with AI explainability, what frameworks or methods should be used to test the AI? This is a question from Chandra.
Yeah, great question, Chandra. So this is really the crux of many of those problems with the functional safety standards in particular. So how do we actually test what is essentially a non-deterministic system? We don't know, and that's why we have to really focus on the intended functionality. The AI is going to go off and do something in a black box largely that we don't know. We're not going to be able to be privy to that. So it's very much following the principles of black box testing, where you're talking about, this is what I expect you to do in this instance, and we have to test cases. We can't know how it's putting all of that together. We're not able to do white box testing to see really what's happening inside, and we're just looking at what's happening at the top level. This is what we put in. Is it giving us, the right sort of behaviors as a response? And how do we do that testing across multiple different responses? I mean, because it's non-deterministic, we don't know it's always going to respond the same way. So yeah, it's very tricky, and that's what these standards are really trying to help us adjust to.
Thanks, Steve, for the answer. I can see one more question in the chat box. How Clockwork can help us in reducing the time taken to make the AI generated code compliant with AutoSAR standard?
Yeah, great question. So that's exactly where our tool, static analysis tools, can help, because we're actually checking that the generated code from the AI system, for example, is actually compliant with those standards. Now, again, in theory, we could train the standards to learn some of those basic rules. So, sorry, the AI models, so they learn some of those rules about the standards and don't produce code that is violating them. And that's very simple to do with some of the basic rules in many of those standards. But it's not simple to do with many of the more complex rules, where we're talking about control, data flow across the entire system, interactions where we've got interactions with bits that are human written parts of the code. You know, this is the same problem we see with generated code in general, actually, from any system, whether it be AI or whether it just be from models that we've already created, you know, as design models and so on. So we can do much of the correctness from a syntax perspective, but it's very hard to do a lot of it from the more semantic and cross-module kind of issues. But we'll talk a bit more about that in the next section. So that leads us on very nicely to the work that we're doing with our tools in order to make them more applicable for AI, but also to AI systems, but also to make them harness the power of AI to really speed up the whole development process. So just quickly, in terms of the future AI opportunities for static analysis, so we're now talking about static analysis specifically. Obviously, static analysis is widely used for functional safety and functional security. So that's where we have a big tie-in with those. Tools like Clockwork, our tool, are capable of very deep interprocedural data flow analysis. So in other words, across the entire system, tracking all of the different data items and how those data items are used in different ways. And from that information, we can produce analysis data on things like, well, have you got any memory leaks in this application? Have you got resource leaks? Have you got concurrency violations where you haven't properly locked some kind of shared resource? All those kind of things are what static analysis like Clockwork will produce. At the moment, that's a long way away from where generative AI is in terms of its capabilities for analysis. So, of course, the first question is, why can't we just use AI to do the checking? Well, it can't do it. It can do basic syntactic checking, no problem. But then so can most compilers. They already know the syntax, they know what they're looking for. Generative AI is more intelligent than that. It can do some other clever things in source code. So it can look for things like comments to make sure that the comments reflect the code, to do that kind of comparison at a small scale. It can look for duplications of code. It can look for things where it thinks, okay, the developer was doing one thing here, they copied this and redid it, and they didn't really consider the changes they needed to make in the copy. So those kind of things are where artificial intelligence, like real intelligence, in fact, like a code reviewer, can really spot things quite quickly. Where it doesn't work is when we're talking about analysis of, say, you know, a code base of 5 million lines of code with some kind of centrally used shared resource that's being locked and unlocked by 100 different processes. That's very difficult for AI to do, just like it's very difficult for intelligence, normal human intelligence to do. A machine, by contrast, can do it very easily if it has a set of rules to follow. So yeah, it's very interesting to see the differences in the types of analysis. But also scale's a problem. So from an AI perspective, we have a certain number of tokens that we can provide it with, and large code bases will often exceed that very quickly. But the point is that generally we are seeing more code being written by AI and more AI creeping into those mission critical systems. So the needs for verifications of those systems are only increasing. At a high level, so we're talking about government level, the risks are clearly recognized. And the formal standards for functional safety and functional security are catching up. But encouragingly, we have that new ISO 8800 standard, 8800 standard, which is obviously being published at the moment. So we have the first example of functional safety catching up, which is really good to see. In terms of our enhanced AI static analysis ideas, we actually have a couple of different areas where we're already spending a lot of time and effort on our research. So really the main facets of this would be, first of all, in AI enhancing the existing analysis results. So what we mean by this is we've already done our analysis. So Clockwork's already running an analysis. It's produced a load of results. Within those results, we can actually post-process that with AI to do certain things of great value. So for example, prioritizing and triaging issues, perhaps, based on past experience. So in other words, crowdsourcing what you've already done and applying that to the new issues. That's something where AI is very, very capable, because it just, in the same way as a human would, it understands what's been done, works out the pattern, and applies that to the new environment. So this is something where we already can see that there's going to be great advantage. Similarly, it's very good, AI is very good at finding patterns in terms of types of issues. So for example, you say, okay, well, I've got a problem here, which is based on this particular variable being used in this way. Find me all of the comparable cases in the rest of my results. And again, AI is very quick and very powerful at detecting those things. So that's one area where we are spending some significant R&D effort, and I do expect us to have some solutions in that area coming into the product this coming year. So in 2025, we do expect to have at least one or two of those features coming through in the product itself. The next one is the AI scanning for additional augmented or complementary factors within the code. So this is where we're talking about things like, okay, can we understand the sentiment of the code? Do we understand, maybe if the comments around the code are applicable for the code as we actually understand it? So this again is where AI can be quite powerful. We've done some work around sentiment analysis, which is where we can detect sort of the changes in developer style, and therefore work out where we have transitions between one developer writing some code and another developer. And of course, on those boundaries is where we would again expect to see more issues. So this is something that's very special. It's something that normal static analysis can't do. And we're talking about augmenting normal static analysis with additional capabilities from AI. At the moment, that one's rather limited by the fact that the AI tools or the AI models out there can't cope with the size of code base that we're often encountering ourselves. So we'll talk about it in a moment, but that one's kind of limited by bandwidth or capability in terms of the amount of processing the AI can do. But another one we can add, and where again we have some R&D effort going into at the moment, is the idea of AI generated checkers. So within Clockwork, we have an open framework for creating new checkers and for enhancing existing checkers. And what we can see is an opportunity for AI, the clever bit of AI, to do the understanding of the problem, and then to be able to actually write something that the engine can check. Now, this has a benefit, because what it means is we can, whereas AI on a small project might work in terms of finding issues, AI on a larger project, it can't cope with that capacity. It's too much. And also the frequency that we would want to run the AI. So we need to run this with every nightly build or every time we have a new commit. AI, it's just going to be far too costly and too heavy to do all of that analysis. But if the AI can use its intelligence to create the rule within our system that's already running and is already running very efficiently, then that brings the benefits of AI to the analysis without having to use AI for every analysis. So again, this is kind of an intelligent use of AI, because we're taking what AI is good at and turning it into something that we can repeat and automate very, very quickly. The fourth one is the idea of AI actually doing some processing of the triaging. So here's the classic case here is, okay, can AI automatically work out which of these issues that we've reported we care about versus which ones we don't? And for the ones we don't care about, create deviations or ignore them or whatever we call it. So yes, we think that is going to be a possibility. Again, scale might be a problem in large numbers of issue counts, but it is something that we can probably do very quickly. And also we can use AI to work out, for example, if, let's say from a MISRA standard, we have a certain type of rule that's been deviated in all cases except one. And in one case, it's been considered a problem. Well, that one we could automatically triage, because we could say, okay, well, every other instance here, you've justified why you haven't dealt with this on this ground. This is the same case. We could apply the same justification. So that one there is another one where we could potentially use AI for the triaging process and really keeping us compliant. And finally, the other one is the idea of actually replacing parts of the analysis engine with AI, because AI could, I think, as we alluded to in one of the questions before, it could actually do some of this work for us. Again, the problem here is scale, because we have to be able to process the whole code base. And there's also a privacy issue, because people don't often want the code to be passed out to an external AI model, for example, to do some processing. However, there is a better solution perhaps to this one, is we continue to use our existing structural engine because it's very good at doing the finding very efficiently. The question is then the processing of the findings and what we do with those findings. So in theory, going back to the first one here, and the other thing we're looking at is that once we have a result from the engine, like here's a defect, the AI could be used to take that information once we've got it and then suggest a fix, or at least be interactive around the discussion of a fix. So our developer can go, okay, I found a MISRA violation here. What should I do with this? And the AI would be able to interpret the result without having to have the source code. So there's no privacy problem. We haven't got the same problems in terms of token consumption. So we're not using as much cost. We're not loading the AI engine model up too heavily. But the AI model could then provide a proposed solution or even auto remediate the problem. So again, we're focusing on not loading the AI model up with lots and lots of data of stuff that it's not particularly good at processing. We're taking care of that within the static analysis that already exists. And we're using the AI to add or enhance what we've got, or to speed up the processing of what we've already found. So before we talk about the additional limitations, I think I mentioned some of them there, but there are some limitations of AI. But I saw that there's a couple more questions in the chat. So one of those from Rizwan about how is functional safety helping the chip design process? And you're right, Rizwan. So yes, there is a lot of documentation. Functional safety standards are very heavy generally. And in terms of chip design, obviously there's separate standards for those, which I'm not overly aware of, because obviously that's in the actual hardware design rather than the software. I'm talking more about from a software perspective. But yes, I imagine if it's similar, then there are a lot of requirements, and a lot of those requirements in software, in our side of things, will result in the testing of something, either through static analysis or some dynamic testing and so on. And that's proving the correctness. So all of that process has to be documented. The test cases or the ideas of how we're going to enforce this will have to be defined, and then we'll have to check against those for compliance. From static analysis, it's relatively quick and easy. We simply say, okay, let's check against a MISRA standard, and we can do that automatically with the static analysis tool, and we can see the results in a compliance report. So I hope that answered the question, Rizwan, but I suspect my expertise on chip design is probably less than yours, so I'm not sure that applies. And then we have another question from Amit, and that's with regards to security glitches in generative AI generated code. Is a real challenge for me? Yes, great. Okay, perfect. I'm glad you're seeing those kind of challenges. That's the same thing that we see, and obviously the standards are trying to guard against. And so does Clockwork support the checking of code as per the cert security standard? The answer is very much yes. So Clockwork has support for the cert C, cert C++, and cert Java standards. There is also a cert Android, which is sort of a half-developed standard at the moment, which revolves around C++, Java, and Kotlin code, and kind of covering the worst of the security vulnerabilities from all of those. But yes, cert C, cert C++, that's right, that one's covered. And it's very, very fast. So as soon as the code is written by the generative AI, we can immediately check it for compliance to the standard for cert. Okay, so going back to that's a great question, by the way. Going back to the limitations of current AI, as I say, one of the things that we found in our testing and our research is, of course, that many of the code bases we deal with from the Clockwork side in particular will be many millions of lines of code. So could even be 50 million lines of code and upwards. And of course, if we have 10 tokens in AI land is kind of words essentially that we need to process per line of code, it would mean that we had about 500 million tokens in our query for one scan of our code base. Well, the current best produced AI models, the Google model, I think is probably the best one at the moment for this, can handle about 10 million tokens in one action. So you can imagine that 500 million tokens is a long way away at the moment. And that's just for the current size of some of the code bases. The other problem, of course, is then the cost, because, and that's the next point, we've got 500 million token in query, and we're running that every day or every time there's a commit. That's just going to have an astronomical price tag. It really is going to be beyond belief. We've had some of our own experience with some of the things we've done in our analysis, and occasionally you'll be surprised how expensive a query can be in terms of something like this when we've got a lot of code. So for this reason, that's why we're not really focusing on the AI models doing any analysis at the moment. That's beyond really the capabilities of where we are with our code base size from a scalability perspective, and the cost as well that we'd want to associate. So really more of our focus at the moment is how can we do something as a one-off task, like generating a checker, or something that's post-processing data and therefore is already filtered and already refined into a much smaller token query. We're talking, for the processing of an existing issue to see if we can auto-remediate will be a matter of maybe 100 tokens or 200 tokens instead of several million tokens. Then obviously it's a massive saving. And also the results are huge that come back from some of these things as well. And so we'd have to already do some filtering of the outputs. So there's various things there we're looking at. The other thing, of course, that is a concern from sending code out is, of course, the privacy. So there's a lot of hesitation, of course, around the idea of sharing our code with cloud AI models. And so we're also, of course, in the solutions that we're going to provide, we will be providing a clockwork AI model, which will be running inside Perforce's own system. So it's not public. It's something that's going to be private within that private cloud environment. But that's still not good enough for some customers. They will need to have the AI models installed locally in their own systems, in their own private networks. And for that reason, of course, in that case, some of the larger, more complex queries, where we're talking, 1 million tokens or above, they're not going to work. We need to have much smaller bite-sized chunks in terms of the actual queries. So again, that gives us a limitation for any of our customers that would not have access to share that, even communication over the internet. Okay, so that's kind of covered the final topic there, and now we will go back to the questions that have been raised in the Q&A box. So I'll quickly respond to Amit's follow-up there. Can I analyze my project to find the presence of any malicious packages or hard-coded passwords and weak encryptions with the help of static analysis tools? Yes, you can. So hard-coded passwords, weak encryption within your own code, of course, we can detect those. That's static analysis. That's what it does. In terms of the presence of malicious packages, so external third-party packages, if we're talking about supply chain security or library security of what you're using, that's something slightly different. That's where we use a software composition analysis tool, and it's talking about the external dependencies. But for the issues that will impact your own code, such as hard-coded passwords, weak encryption, tainted data being used without prior checks, all of that kind of stuff, yes, that's exactly what Clockwork and that's what static analysis should be detecting.
Steve, we have one more question in the chat chat
thanks,
box.
Akash. Yep.
How easy is to implement Clockwork to scan the free RTOS project to make it more compliant to ISO 26262?
Okay. Yeah, so the free RTOS, I don't know what that's written in, I guess C, C++. So scanning it and making sure that it's compliant to, say, MISRA would actually be relatively easy. Fixing it under MISRA might be a little bit more tricky. So we'd have to then probably make a decision as to how much we would want to resolve the issues that are detected under MISRA, or how much we'd want to apply deviations. I presume we'd want to apply deviations where we could and only fix or resolve things like the mandatory requirements. In which case, that's not too bad again. So it's still quite a lot more work there, but it's not terrible. The problem is that that's only half the story. So the static analysis piece is not too difficult. The harder part is actually then having a requirements definition for every functional behavior within FreeRTOS and testing that against those requirements. That's a much bigger task. That's on the dynamic side, but that is required by 26262 as well. So it's not easy, but certainly the clockwork piece in terms of scanning is very trivial. And I see we have another question that's popped up in the chat. Is that right? So can static analysis like clockwork handle the complexity of AI-driven software? So AI-driven software in terms of AI created software or AI interacting software? AI interacting software, or the AI models themselves, of course, they can be scanned with clockwork, and that isn't beyond the capability of static analysis in general. And it should find valuable information for you. It will find issues, of course. So those happen. And in those cases, yes, we believe that static analysis will be a big benefit. It can certainly handle it, and it can certainly report the results for that kind of code base. And then we have one more question, actually, with regards to the Android code base. But I looked at the AOSP project, Android Open Source Platform project. Actually, with generated AI code, and can Clockwork handle this? It's 12 million lines of code. Actually, that's just the C++ component of, I think Android 12 or 13 was about 12 million lines of code of C++ alone. But actually, when you take all of the code together, the latest Android is, including the C++, the Java, the Kotlin, all of it together is actually over 50 million lines of code. And yes, Clockwork can process that. And depending on the size of your machine, we can process that in, sort of 10 to 15 hours. It's a big code base, but it's possible. And Clockwork is one of the very few tools out there that can actually process it.
Thank you, Steve, for all those answers. And now we would be moving to our next session. That will be, we will be doing a quiz. And Pooja will be sharing you the link in the chat box. Please remember to rename yourself, because we are giving you some exciting gifts to all the 3 winners. So Pooja, please, can you share the link? Yes, so the link is now in the chat box. Please go ahead and rename yourself, and do not forget to rename yourself, because we are coming up with exciting gifts.
Captain Space, Sivaneshwaran, Unlucky Queen.
Can I have more registrations, please? I can see only
Mr.
13 people
Neil
have joined till now.
Solanki. Lucky Ak, Palani Velu. No Name. KS. Rodamafia.
Guys, please do not forget to
Chandra.
rename yourself. We have 16 participants right now. And do not forget, we are going to give to top 3 only.
June.
Yes, you can start the quiz now.
Quiz.com. Play and create.
Which standard extends
Haunted
ISO
King
26262? ISO/PAS 8800.
Haunted Flower joined.
What is the primary goal of functional safety standards? Prevent system failures that could harm users or property.
Congratulations to all three
Which is a key requirement
winners.
for high-risk AI
Our team will
systems
be
under the
reaching out.
EU AI Act.
Oh, we have one more question.
Accuracy, robustness, and cybersecurity. Which of the following is not a challenge in using AI for static analysis? Lack of global AI adoption.
Final question. Double points.
Which standard focuses on secure software development practices for generative AI? NIST guidelines.
Third place. Raman. Second place. Palani Velu. And the winner is Ted.
Congratulations to all the winners. So our team will be in touch with you guys to deliver the gifts. And thank you so much, Steve, for this fantastic session. And thank you all for attending today's webinar. I hope you found it informative and valuable. So by participating in this session, you have gained practical insights into managing risk and reward. So we will be dropping a link in the chat box. Please, if you require any kind of demo sessions, please fill out the form. Our team will reach out to you to schedule one-on-one session, particularly for clockwork demo, right? And thank you so much, Steve, again for the fantastic session you had. Please don't hesitate to reach out to us in case of combos. Thank you, Steve.
My pleasure. Bye-bye.